Okay, thanks for coming out to the June 2021 event for the Atlanta Kubernetes Meetup, folks. I'm glad to be back after missing the event last month. It happened to coincide with my 8th wedding anniversary, so I wasn't able to attend, but big thanks to Joe for holding down the fort while I was gone. As usual, we will start off with a call for hiring announcements in the community. So anything that's kind of related to Kubernetes or the cloud native technology space, you can go ahead and post in the chat. And after the news segment, I'll read those aloud, and those will also be included in the show notes. If you'd like to share some information around relevant hiring outside of the event, you can always PR those into our GitHub repo as well, which is Kate's ATL on GitHub. All right, with that, I'll go ahead and hand over to Joe for the news.
All right, let me share my screen again here. And, thumbs up from somebody on the panelists. Yeah, awesome, cool. Yeah, so welcome everybody. Lots of stuff going on in the Kubernetes world over the past month or so. Let's start by reviewing where we are in the current Kubernetes release cycle, which is the 1.22 release cycle. We did have a release of the version 1.22.0 beta 0 released within the past few days or so. So everything seems to be progressing along with that. There is one open critical bug left to be squashed in the project. And this is around some of the new security seccomp stuff implemented and with the API server and whatnot. So people are working on that. Code freeze is July 8th, and then July 9th, I believe, is the requirement for documentation for any enhancements and such. So if you're working on things, it's getting down to the wire. We did have some fixed releases done, and I don't remember all the details here, but I think there was some there was a snafu in the Kubernetes release team process. So there were some other incremental dot releases that were put out that they do kind of ask that you skip those and use these releases here. So 121.2, 120.8, 119.12, and 1.18.20. And just a reminder, this is the last fixed release for Kubernetes 1.18. So make sure you're looking to get forward on your versions here. Getting into some of the promotions, the cron job version 2 API was promoted to GA. So just calling that out. There is some stuff there. If you heavily use cron jobs, there might be some stuff you need to change in that going forward. Another thing in deprecations, the kubectl record feature, which was one of my favorite features with kubectl, is being deprecated. There is a slightly different usage pattern being recommended as a replacement to use request annotations instead. And I'm going to talk about that a little bit more in a second in the PRs of notes section, because there's some things related there, but some pretty cool stuff there. Another thing from the SIG storage, balanced attached node volumes. These are being deprecated, and there's a questionnaire out to the community right now to kind of assess how many people are using this feature and whatnot. So if you are using this feature, start looking at the mailing lists and get in contact with the SIG storage folks to at least communicate that to them to help inform the process of that deprecation. No major CVEs that I saw within the project, which is awesome. And then let's get into the PRs of note. So pod security admission. This is an interesting one. We've had the drama related around pod security policies for a while now. They have been officially deprecated. And there is a lot of work being done to work out a sort of intermediary solution and then eventually like the long-term solution. So there's a lot of things around standard security standards recommended by the Kubernetes community, and those are documented out there. And this is sort of an entry admission controller that will help address some of those. It is an alpha feature, so it needs to be toggled on via API server config flag. I'm not going to go into a lot of detail there, but I do think they've done a good job of capturing the different modes that give a little more flexibility than what the pod security policies did before, and a little bit lower barrier to entry to adopt this. So I've linked to the KEP as well as the pod security standards as well, if you want to go in and review that later. Kube API server now supports distributed tracing. I think that's great. You know, we had some content a few months ago around the distributed tracing concept, and having that stuff integrated into the core Kubernetes components is awesome. So this is the kubectl command metadata and HTTP headers. This is the one related to the kubectl record replacement that I mentioned. And so basically what this does is it captures the details of the kubectl command and in the HTTP headers being sent in the request to the Kubernetes API server. So there's a lot of detail on like what arguments are being passed and different things of that nature that are going through there. So from an audit perspective, you still have all the same information, and then you can utilize that information in different ways with different types of tooling that you can build in a cluster itself. And then I haven't read through all the details in the KEP here, but they are taking into consideration some things where there might be some sensitive arguments and things of that nature. So you can mark that in the request as well, which is pretty cool. Exec credential provider. So this is an enhancement that is pretty interesting. So the Kubernetes exec model has been around for a bit, and there's lots of different things that you could do with it. And I think that's extending. But in a world where, you know, a lot of enterprises are requiring things like two-factor authentication, you know, some security folks frowned upon the kubectl exec model because it had the potential to bypass some of those multi-factor authentication methods. So this is kind of taking into account those things as kind of a primitive, like first-party support for some of those things. There's a couple different models, like if available or always, and different things like that, where essentially it controls how the interaction between the user, the identity provider, and the Kubernetes environment performs in those other situations beyond just retrieving a token, but in the exec model as well. So some cool stuff there. And then kubeadm control plane run as non-root. This is a big win for security. I love to see that there's still a ton of work around all the seccomp stuff and taking all the core Kubernetes pieces and just continuing to make them more secure. Moving over into community news here, this is a project called Forklift that is basically can take a VMware virtual machine and convert it to a KubeVirt environment. So won't go through a bunch of detail here, but it's pretty interesting. And I remember back in the day when virtual machines started getting big in enterprises, there was a lot of tooling where you could take like an existing bare metal machine, run a thing on it and capture that and export that into like vSpheres or KVM to kind of do the conversion from bare metal to virtual machines. So this, again, I haven't read into all the details here. I may be way off base in some assumptions that I'm making there, but seems some similar in concept to help migrate some things from traditional platforms like virtual machines into containerized platforms. vCluster, virtual clusters within namespaces. This one is interesting. Being on a team that provides a Kubernetes platform for an enterprise internally, multi-tenancy is obviously a big concern, and there's a lot of things that Kubernetes does really well, and there's a lot of things that Kubernetes doesn't do super well, and multi-tenancy is kind of one of those things that straddles the fence with core Kubernetes features. So vCluster here essentially takes a higher order primitives over and beyond a namespace and allows you to kind of group multiple namespaces together as a tenant. And so building on Kubernetes CRDs and things like that to define those higher level APIs, this allows you to deploy a cluster within the namespace scope. So you have like a base cluster, you have like a tenant one namespace, and then you can create a virtual cluster running within pods inside that namespace. So whole nother level of isolation for a multi-tenant model and whatnot. And there's a lot of flexibility built into what they've exposed from a configuration perspective, and lots of benefits and things to that model. So pretty interesting. Capsule, this is again in the kind of Kubernetes multi-tenancy space. This builds onto some of those same things where you kind of have the higher order APIs to go through and be able to group the namespaces and prevent the cluster sprawl from like every tenant has its own cluster. Everything uses and builds on top of native Kubernetes resources. So it's GitOps friendly. Really cool models here. They have some nice demos as well. And the breakdown between like tenant operators, tenant owners, and things of that nature. So again, if you're working in and around critical multi-tenant Kubernetes environments, something cool to look at. Porter LB, so this is a load balancer for bare metal Kubernetes. Basically trying to bring in a lot of the functionality that public cloud providers and managed Kubernetes services provide out of the box in those environments. Bring that down to bare metal Kubernetes environments or even just on-premise Kubernetes environments. Builds on a lot of the same concepts. I can't remember if this builds on top of like Metal LB in some way, or is kind of a shift to the right for Metal LB. But a lot of the same things with using stuff like BGP and equal policy multipath routing and IP address pool management and stuff like that. So it sounds a lot similar to Metal LB. Haven't played around with this yet, but it's definitely on my to-do list. Reconciler runtime. This is a project that I think is either out of or at least backed by VMware. Yeah, out of VMware Labs. And this is pretty cool. So if you've ever done any development around Kubernetes operators or controllers, you've probably come across controller runtime, which is a set of sort of frameworks or libraries that you can use to help speed up your velocity in developing controllers and operators and things of that nature. So this picks up kind of where controller runtime leaves off, which controller runtime takes you up to the point of the reconciliation loop. And then reconcile runtime builds a lot of different features and frameworks where you can use to control how that reconciliation works inside that flow. So really cool to see this. A lot of the stuff that we talked about in past months around like the Kubernetes duck typing and things of that nature come into play here too as well. So really cool to see that proliferating out. And last but not least, we have source code location and JSON login. So this is actually in the wrong place. This was a PR to the Kubernetes project itself. And basically what this allows you to do is to kind of point and call out what source code is involved in a particular event that you're able to log. And so it can log those things. So as an operator, when you see a log come through using the structured JSON log in the Kubernetes project, you'll be able to like see information that kind of points you at the source code behind that component or event. So if you need to go and look at like, you know, from a stack trace perspective or anything like that, you don't have to go and like search through GitHub and things like that. It should be kind of a direct link involved for you to trace that down. So really handy for troubleshooting low-level stuff. And that wraps up this month in Kubernetes news. So hand it back over to you, Alex.
Awesome. We had one hiring announcement. Looks like BlackRock is hiring a platform engineer. Mr. Rumstead here mentioned that they are located right on the Beltline over by Ponce City Market. And it looks like they're doing container migration right now, moving off of binaries running on bare metal. So if you want to get it on the ground floor to container migration, it sounds like a good opportunity for it. It sounds like Eldon's also jockeying to take over as our weatherman on the meetup. So I'm not sure if that counts the job announcement or not, but moving on from that, I want to thank our sponsors. As always, thank you to SalesLoft for providing our meetup and Better Times, our the space where we meet and food and beer and things like that, which I'm sure we're all looking forward to getting back to. During the meetup, or rather during the presentations, you can ask questions using Zoom's Q&A feature. You should see it right in the bottom bar there, Q&A. You can enter questions, and Adrien has asked us just to read them out to him as they come up. So as we have a moment, we'll interject with those questions for you, and they'll be answered live by the presenter. And with that, I will go ahead and introduce my actual coworker and our first presenter, Adrien Trouillaud here. He's the creator of Admiralty and a senior software engineer at Datadog. And he's going to be doing an introduction to Admiralty for us. Adrien, go ahead, buddy.
So, thanks for the introduction. Showing my screen. Presenting. Can you see my screen? Great. Yeah. So I created Admiralty to make it easier to manage multiple Kubernetes clusters at the application level, which is if you have a lot of clusters spread across different regions, clouds, on-prem, etc., and you're trying to deploy your applications either to some of them or across them, and for different reasons, the pieces were missing to make that happen. It's a lot of people doing things differently, and I believe that there's the Kubernetes API is actually not restricted to single clusters. Like it can be decoupled from Kubernetes, the cluster orchestrator. And so that's the gist of Admiralty. And this is a typical use case. Admiralty can be used in many different, like in various multi-cluster use cases, like services, batch. It can be used for active disaster recovery. It can be used just because some data is in some region and some other data is in some other region for batch workloads. And to make it possible to handle all those different types of workloads, well, there's already an API that can handle all those types of workloads, and it's the Kubernetes API. So the way Admiralty transforms the Kubernetes API into a multi-cluster API is by taking pods and shipping them to other clusters. The regular higher level APIs like jobs, deployments, even stateful sets, that's a work in progress, are, but definitely possible, are all boiled down to when they're reconciled to pods, which represent containers on real nodes, usually virtual machines or machines. But with Admiralty, the pods run on virtual nodes, and those virtual nodes represent clusters. So we're basically inserting like an indirection, which is the virtual node, and that uses the Virtual Kubelet project, which is used by other projects in Admiralty. So yeah, let's look at this example. So because I talk, but so like I need to describe this diagram that we have in front of me. So I'm sorry, I'm shamelessly reusing slides from a presentation that I did at KubeCon last year, but like I need the slides, so here it is. So here are your higher level APIs. They can be anything. They can actually be third-party APIs. Admiralty works well with APIs that aren't necessarily your deployments. If you have some custom APIs that create pods in the end, they're compatible with Admiralty. And so here in this example, it's just jobs, but I know Kubeflow can work with Admiralty, Argo Workflows, Argo CD works because it creates your manifest, so deployments and jobs, etc. And so they all create pods. And with Admiralty, those pods are scheduled to virtual nodes, and then delegate pods, what we call delegate pods, are created in other clusters. And this whole logic here is of scheduling in the source clusters and scheduling in the target clusters is what Admiralty is in charge of. Which virtual cluster, which virtual node do I choose, or which real node do I choose in the target cluster, and how to communicate between the schedulers in the different clusters is what Admiralty does. You can organize your clusters in many different ways. The most popular way to organize your clusters with Admiralty is to have a cluster that you elect to be your management cluster. This cluster doesn't actually run necessarily run your compute workloads. It's not on your critical path. It's not on the data plane, but it manages it manages your deployments, and you connect it to your workload clusters. But you can there are other ways to organize your clusters for cloud bursting, or I've worked with University of California in San Diego and a lot of other universities in the US and across the world who are building a federation that is decentralized of all their clusters, and they don't have like necessarily an entity that they don't want an entity to control their, like a central entity to control their clusters. So they just participate, give access to some clusters, but not others, depending on agreements. And that's how they work together. And so a key aspect of making clusters work together is by connecting them. And the way they're connected is nothing, is not specific to Admiralty. Admiralty relies on common building block of authentication and authorization for Kubernetes to connect clusters. And then to make them work together, it relies on a common building block, which is control loops talking to the API server within or across cluster boundaries. And so to authenticate across clusters is kind of the tricky part of this, because there are many ways to do it. You can use Vault, you can use your cloud providers IAM, you can use your own custom role IAM. You just have to have basically clusters have to trust each other. So you can even do that what I call the cheap way, which is to use service accounts of one cluster and like just copy the token in the other cluster, and you're good to go. That's good for experiments. But what you want in production is more likely something that works with certificates and you know, a whole PKI and federation, things like that. Federated authentication. So and then authorization uses the common building block of RBAC, Kubernetes RBAC. One cluster can allow another cluster or another identity in another cluster to create pods, to update pods, to copy config maps, copy services. Because let me backtrack a little bit. So not only does Admiralty schedule the pods, but then to make an entire application work, you need a lot of other pieces. You need config map, secrets, services, ingress, and all those things are basically more or less like one way or another connected to pods. A pod needs a config map. A service targets pods. An ingress targets a service, which targets pods. And so there's a way to follow those connections and make dependencies and dependents follow the pods. And that's one other thing that Admiralty does. The scheduling part, I want to talk about after the demo. It uses the scheduler framework, which is another thing that is provided by Kubernetes and that you can use in many different ways, like for batch scheduling. Like there are people creating their own custom schedulers, and they rely on the scheduler framework, which is amazing. So let's switch to the demo, and this demo is fairly simple. It uses kind to, let me clear this. Oh, I was here. Okay, I have some port forwards open to Argo CD because so this demo is an integration between Admiralty and Argo CD. Argo CD, for those of you, I know a lot of people are not familiar with it, but for those of you who are not familiar with Argo CD, it's a project by Intuit, and I mean started by Intuit, but it's a project that is has been adopted by a lot of companies, a lot of people, and has a lot of contributors, and it's GitOps for Kubernetes with a nice UI, and you can connect your clusters to Git repositories, and Argo CD will sync with your Kubernetes clusters. It will sync the manifest. So But let me show you. I have the clusters in this demo. I have a management cluster that I call CD and 2 other clusters that I call EU and US, just as a. I see there's a question. Yeah, I mean, you can bake your configs and secret into container image, of course, if you want. I'll follow. And so, so I don't know if attendees can see the questions, but Alex, maybe you're in charge of asking the questions. So sorry, I won't go ahead and read them and answer them right away. I'll let you interrupt when you want.
I was going to ignore Alden's sass, but
ignore my heckling, please.
Okay. So yeah, simple configuration, simple what I call a cluster topology, where that's just like a management and 2 workload clusters. And then I have Argo CD installed and running in the management cluster, and the management cluster only, and not the other clusters. And so it's here. I have a port forward open to Argo CD, and I can see my list of applications. And I'm going to create an application. And my application is here. It's on GitHub. It's a simple service that has 2 deployments, 1 service and 1 ingress. And sometimes in the demo, I have multiple clusters in each region. Here, there's only 1, but so each deployment targets 1 region with a node selector. That is pretty standard. You would use that within a cluster to, for example, target an availability zone, or to target some nodes that have some capabilities. Here, I used a node selector to target a region. And it runs a Hello World application that just, actually, it doesn't matter for this demo. So it runs something. And another one that targets Europe. And then those dependencies, or rather dependents of those deployments, which are service and ingress. So with Argo, you can create an app. You can do this in the UI, but you could also do this with an app manifest that just says what I'm going to fill in this form as a YAML document. But we're going to call our app Hello World. Argo CD has this concept of project. We're going to use the default project. We're going to sync manually. And I'm going to use the repo URL. Here. Just use the root path. And so with like when you use Admiralty and Argo CD, you target the same cluster. That's something that's so Argo CD has this is able to deploy applications to other clusters. The way it does it is that it deploys the whole thing. It'll deploy it will basically apply the whole manifest on a different cluster. And by doing that, you basically have to choose which cluster. You can't really be smart about scheduling. If you replace your you can't spread one deployment across multiple clusters, or replace your clusters but keep your manifest the same. But with Admiralty, you just deploy your manifest in your management cluster, and Admiralty takes care of moving the pods. So it works at a different level. And the way we use Argo CD is from Argo CD's perspective, we're just single cluster, but Admiralty does the multi-cluster part. So here I just choose in cluster in the default namespace. So this is my app. that is, as we saw a little earlier, is composed of 2 deployments, a service and ingress. It's currently out of sync because nothing's deployed. So, so you click sync because we decided to sync manually and synchronize. And so we see here live in action that Argo CD is syncing our manifest with the cluster. And let's have a look at. So it looks like sync went okay. There's still an out of sync with the service. And I want to know. Selectors different. Okay, that might be because I didn't configure it for there's a you can tweak the way that the labels are considered for to see if the sync was successful or not, and to make it work with Admiralty correctly. And I may not have done that when I prepared this demo, but you can make it look like it's in sync. But let's have a look at the actual resources. So first of all, I want to show you the nodes. Just increase the font a little bit. I want to show you the nodes. So I'm looking at the nodes in the management cluster, and these are kind clusters, so they have the single nodes. And there are two virtual nodes here that actually represent clusters. And if I look at the pods, yeah, let's make them looking on a single line. You'll see that the deployments I've created 4 pods, 2 per deployment, and they run because I use output wide. I can see which nodes they run on, and so the pods of those deployments in the management cluster run on the virtual nodes that represent the other clusters. And if I look at the pods in one of those clusters, I'll see that they run on the single node of that cluster in kind. So virtual pods run on virtual nodes, and delegate pods run on real nodes in the target clusters. And that's how it works. So what happened to those services and ingresses? Well, in the US and in EU, there's a Hello World service and a Hello World ingress. They follow. Admiralty made them follow. So here in kind, I don't have really the networking side of things to show you, but what you would do with a cloud provider is using those ingresses in the different clusters. They would control load balancers and DNS or global load balancer, and you can put tooling in place so that you have a single global endpoint that can target your application in multiple clusters, and then if pods are unavailable in one cluster, traffic goes to the other cluster. Yeah, that's it for this demo. And also, yeah, there are videos online that you can find that show Admiralty with Argo Workflows. It was at a to find it. It's a CNCF user group research meeting where I showed Admiralty with Argo Workflows, because the folks there are interested in workflows. And there are videos about this, but on EKS, for example, and with the whole networking working. But I wanted to keep it simple for now, because I want to dive into the how the scheduling works, which the part that is unique to Admiralty. So let's get back to the presentation. And let's go back to the scheduler framework. The scheduler framework is, so it's in the Kubernetes upstream code. It's an interface or a bunch of interfaces that you can use, and it's more like a, it's a framework, so it's a lot of things. it's interfaces, and then a few helper functions, and so basically you can create a Go program, like a main package, with very little code that you can compile, and you have a Kubernetes scheduler that works exactly the same as the standard scheduler, with a few exceptions. And those few exceptions are inserted with at different points in the scheduling cycle and the binding cycle. So how is a pod scheduled in Kubernetes? It's the two main things are that you want to filter your nodes, which nodes are eligible to host the pod due to labels. Do they have do they have the storage? Do they have the, I don't know, GPU? Do they have, like, a lot of considerations? Do they have the resources, CPU, memory, in a free that are already requested? And then you score them, and using different rules. The highest scoring node is the one that should host the pod. So the node is reserved, and another pod can be scheduled. This is like a one pod at a time kind of thing. And then once a node is reserved, like asynchronously, it can be bound, which is, make sure that like I think during the binding cycles, the volumes are bound, and like everything's make sure everything's running basically, and then confirm that that the pod has been scheduled. And this it can still fail and go back to the beginning. And so Admiralty uses some of those like insertion points to change things a little bit. So here's Admiralty in a sequence diagram. The source pod is the pod that was created by the replica set, which was created by the deployment in our example. And Admiralty has an admission webhook that mutates the pod. For example, it says, well, I want to use the Admiralty scheduler, not the default scheduler. I'm going to change a few things to make things work, and I'm not going to go into details here, but we need to mutate the pod a little bit. For example, to tolerate the virtual nodes which are tainted for other non-multi-cluster pods, and then the pod enters the proxy scheduler, which is a custom scheduler using the framework, and during the filter, I call it a hook, but it's not really a hook, because hooks are another scaling concept where you can like call an external service as a hook. But so the filter step is more a better term. Admiralty actually creates an intermediate resource that is called that we call a pod chaperone in all the other clusters. That's one of the algorithms. There's another algorithm that we can talk about if we have time. In all of the other clusters. And those, so the pod chaperones are have they're here for two reasons. They are kind of a communication channel between the clusters. Annotations on the pod chaperones are how the schedulers talk to each other. And so when one scheduler has something to tell to the other scheduler, it annotates the pod chaperone of the corresponding pod. And the other reason that we have pod chaperones is that if a pod is somehow evicted or deleted in a target cluster once it runs, and the connection has been lost between the source and target clusters, for like an intermittent loss of connection, which can happen in some use cases. The pod chaperone, which is local, will make sure that the pod is recreated. Like it's kind of like a one replica set, just for the real pod in target cluster. So if a pod chaperone is created, a pod is created that has the same spec. Now, those pods are handled by the candidate scheduler, which works almost like the standard scheduler, and it goes through filtering, scoring of this time real nodes, and once a node is selected, it is reserved, and so the annotation is created on the pod chaperone. The proxy scheduler sees that, so it sees that from all those candidates that were sent, 2 of them are actually like, and here in this example, like there are 3 targets, 2 of them could work. So we score, and we select one to, for example, to have a nice spread between regions, or to have a nice spread between clusters in the same region, like depending on the use case. And we decide to allow this one. That's an annotation again. The candidate scheduler sees that annotation and in that cluster, sees the annotation and binds the candidate pod in that cluster. The others are still waiting. They're like, okay, I passed this. Like, I could. They're waiting, but they're not binding their pods yet because they're waiting for this allow annotation that will never come. So going back to the proxy scheduler, okay, binding has worked in the cluster that I have allowed. Great. Now I can say that this pod is bound. That's how you see from a user's perspective in your source cluster that you went from pending to running. And because there's this feedback loop, and all the other candidates are deleted. So that's how you ensure that. That's how you schedule across clusters in a what I call a smart way, which is you can use node selectors that not only work on, you can schedule at 2 levels. You can use node selectors at the virtual node level and at the real node level. So you don't have to recreate an entire representation of what clusters can have what resources. You don't have to. I see in other solutions a lot of scheduling logic going on here, but there's already a lot of information there. So just use it. And then this is how this algorithm makes it possible to use all the information of the clusters and not just a partial view or an aggregated view.
Adrien, in this process here, are the scheduling decisions made, or I guess the reconciliation of pods on the remote target clusters, is that blocking from the management cluster, like the action, like say I kubectl apply something or whatever onto the management cluster? Does that wait? Is that an actual blocking action? I'm just thinking in terms, if I have today, say I have 100 Kubernetes clusters and my developers are split up, some, kubectl apply to cluster 1, 2, 3, some 4, 5, 6. But in this model, everybody would potentially be, kubectl applying to the management cluster. And I could see that getting pretty busy. Are you doing anything there, with the scheduling piece or anything else to kind of account for that type of thing?
Yeah, so So your kube control apply works the same ways, right? So it's not, I mean, it's not blocking on the CLI, right? But maybe you're talking about, are you talking about the scheduling cycles of the proxy scheduler in the management cluster?
More like status reflection of like the thing that I did until like the time it's ready and things of that nature.
Yeah, it's I mean, it's pretty quick. It's I mean the blocking factor is, or like the where it could go slow is in the scheduling cycle and the proxy scheduler, which handles one pod at a time. So just like in a, basically the scheduling performance limit of a single cluster applies to the management cluster, but that scheduling cycle performance is really good in a single cluster. I don't remember the numbers, right? But it's something that has been really optimized and is really important for Kubernetes single clusters, and that's how you can have clusters that have tens of thousands of nodes, and it still works, right? I mean, it's not like, there's a lot of factors like number of nodes, how often you schedule, how many pods. There's so many factors. So like just saying tens of thousands of nodes doesn't mean much, and that's stretching it. So that's, I think, I don't remember what was the biggest cluster, or what is currently the biggest cluster that has been published. But you know, if that becomes an issue, then it's something to look at and optimize. But in most use cases, your main issue is operational. Is you're trying to simplify things. You're trying to choose cluster. You're trying to your main concern is not necessarily your scheduling speed. Does that make sense?
Yes, thank you.
Yeah. So if well, there are no other questions. There are some Admiralty can be configured for situations where you have your own scheduler. So because in the previous algorithm, I show a proxy scheduler, a candidate scheduler, and those are owned by Admiralty. So basically, you would have to recompile them if you want to add your own custom scheduling logic. So if you want to use a third-party scheduler without recompiling things, or because you can't, because you're using, for example, Fargate, then you can use an alternate algorithm that that doesn't send candidates to all clusters at once, but sends them one after the other. Like at first we score the virtual nodes, we score the clusters with aggregated information, and we send the candidates one by one. And the first cluster that can successfully host the pod takes it, and so we can go fast and still be compatible with third-party schedulers. And there was another circumstance where this was useful. It's not necessarily only with third-party scheduler. It's oh, I'll have to think about it. Sorry, that just I can't recall. Yeah, so let's go back to the main slide. If you want more information about Admiralty, there's a website, documentation. I'm always happy to chat about it and talk about use cases and welcome contributions, of course, of all sorts. You know, documentation, code, features, ideas. Yeah, that was a pleasure speaking here.
Thank you much, Adrien. That was awesome, man. It's very cool technology. All right, it doesn't look like there's any questions pending right now. If you have them, in the last second, get them in. It looks like we don't have any others. So Thanks to Adrien. And now we're going to move to our next presenter, Mr. Eldon Stiegel, longtime member of the meetup. He's going to be doing an intro to container, well, I guess CNI rather, tooling. I think specifically with the security tilt. And I'll let him elaborate on that. Thanks again, Adrien.
Thank you.
Yeah. So well, let me try to share here. Okay. So I only have the one desktop. Can y'all see my screen? Yeah, sweet. So, I think Alex was a little generous with intro to container BPF. I'd like to talk a little bit from the perspective of a security team member in an organization that's adopting Kubernetes, and what the security team has probably been using historically, what we would like to be using, but how we kind of get there from where we are. So I've been in the IT and sort of security startup industry about 15 years, 10 years primarily in the cloud, security adjacent, and I've worked at larger companies and I've worked with much larger companies, but I'm kind of discovered at this point that I'm a small company guy. I'm good at about 5 to 50 people. I like to wear a lot of hats. I like to talk to customers and write code and, hack on this and that. And let's see. So I want to talk about the sort of the problem statement. So historically, we've had a certain level of modular security. There was the network. Applications ran on the network as we knew it, which was probably things plugged into physical switches at one point in time. Then it became virtual machines, which were plugged into after they finally implemented it. It used to be every EC2 instance was just on the internet. And then they added security groups and private EC2 instances and private VPCs and VPC flow logging and VPC traffic mirroring. And some of the tools were able to be repurposed from that original, this is a physical switch that I'm plugging into, to this is a virtual switch where I'm mirroring traffic from these EC2 instances or these GCP instances into some of the tooling. And so I'd like to give a brief overview of some of the tooling and sort of talk about how it was oriented, and then talk about how we can do some of the same things with containers, some of the things that are going to be a challenge from the security perspective, and some of the tooling that we can hope to implement to make those things better. So really, on a small security team, your objectives are to monitor the infrastructure for security incidents, to respond to those security incidents. And at the end of the day, it's really a tricky and kind of thankless job. You either end up being a cost center and also probably somebody who was in some form or fashion responsible for a data leak or an intrusion or something like that. Or you're really good and you make it look easy. And executives say, this guy, he just makes it look so easy. What are we paying him so much for? So yeah, so I haven't talked a lot about Kubernetes yet because most security teams aren't ready for Kubernetes. Most security teams, given the points 4 and 5 from the previous slide, they're really struggling as is to maintain budget to maintain good people, because as we know in this industry, good people are hard hard to obtain and also hard to retain. So everybody is kind of looking, and I really liked this picture. Everybody is really looking on a security team to move up this ladder. So you start out, you're vulnerable. Who cares about cybersecurity as long as it doesn't affect us? Then you kind of move to reactive. Okay, there was an incident, like, I'm not gonna name names, but I have worked at several places where we got hey, the build is broken. Oh, why is the build broken? Oh, well, our credentials were automatically disabled by our credential provider. Oh, why is that? Oh, well, they detected a leak on GitHub or Bitbucket or Pastebin or something like this of some developer or operations person or a security person who reused a password, check something in. So in that case, you're really reactive. You're like, oh, something leaked. Turn off the faucets. Like, let's try to figure it out. Then you move to a place, hopefully, where you're compliant. Maybe you've implemented some controls. You've implemented SOC 2. You've implemented ISO 27000, and you have kind of a sense of what's going on in the organization. Like, this is frankly where many organizations sort of are angled, but many are not there. But that's where they're trying to get to. Proactive. This is a great place to be as an organization, and I think we're seeing more and more of this. This is definitely where Google and some of the other organizations that have been able to hire like those really A-grade sort of folks, people that are doing fuzzing, and people that are building more sophisticated network scanners and things like that. They are absolutely there. And then finally, you get to resilient, which is, everybody drink when I say shift left. All of your security has been shifted left, and your security organization is well integrated with your development organization and your operational organizations. Very few companies are there. So the part of the issue is we're in Kubernetes. Kubernetes, like we have a news segment, and every time it is full of wild and crazy things. And so a lot of these tools, which I'm kind of going to give a brief intro to, are tools which are working on making the jump, haven't made the jump yet, but could make the jump if organizations are willing to pay for them. But most of them are based on one of two things. They're based on either, from the networking component, they're based on either packet analysis or flow log analysis. So packet analysis is exactly what it sounds like. I take all of the packets that come in to your network interface and analyze them against a set of signatures. Sometimes I remember the flows. Sometimes I remember, certain parts of the header or something like that. So Zeek and Suricata are two pieces of tooling that implement these things. And there's something that many security companies use, or many security organizations within companies use to do their network security monitoring. So as a networking person, I can go in, I can say, oh, what happened this week? Oh, well, Apache had a vulnerability. Okay, I'm gonna write my Heartbleed signature, deploy it on all my Suricata or Zeek, analysis boxes, and then I'll know if this happens to me, and I'll be able to turn off that TCP connection, shut it down, add that IP address to a network access control list, something like that. NTOP is another one. These folks are really kind of some of the original promoters of network packet analysis. They wrote several plugins to the Linux kernel to basically speed this stuff up and similar and the tooling on top of it. But the tricky part is all of this stuff is really interface centric. And as we know, with Kubernetes, a node doesn't have one interface. A node could have 1,000 interfaces. I also wanted to call out the Linux auditing system, just like a node could have. And so that's called an AF packet based analysis tool. So it's opening a network interface with a raw packet connection. It's getting all the packets, it's analyzing them, and hopefully it will find the thing that you need. Also, I wanted to talk, but I also wanted to talk about there's 1,000 interfaces. Now there are also 1,000 file systems, right? So audit D is kind of the historical gold standard for the thing that is watching every file that gets opened on your system and saying, hey, wait a second, Java shouldn't be opening Etsy password, or Java shouldn't be accessing, some obscure C library or curl or something like that to do a network request. This doesn't look right. Elastaflow is another sort of contender here, and they rather than just consuming packets, they consume something called NetFlow, which is something that many historical and to current today. So you can get NetFlow from a tool called sflow, which works. And if you go to I think it's sflow.net, something like that. Yeah. So it gets updated, yearly almost, not exactly the most aggressively updated tool. And it's, it's going to represent something that's, see, it does support Docker and systemd containers, but does it support containerd containers or cryo or whatever thing you want to talk about next? Hard to say. And so with that, your security organization may have these awesome visualizations that at the end of the day kind of go out the window when you're talking about, something like Admiralty. If you're looking at something like that and you have somebody attacking your North American data center, then, maybe you shut that down, but they just get redirected because, the internet, finds breakage and routes around it to all of a sudden they're attacking your Southeast Asia data center. What's the next plan? So those are some of the challenges. Of course, cloud has similar tools. They have security groups, they have VPC logs, and they have virtual port mirroring. All of which we can use these tools that we've used historically to get to a similar place with some of our security awareness. But many of these things also end up changing because they're stuck in the pre-container era. So for example, dynamism. VPC flow logs are great because they tell you which network interface your data is coming out of. Now, let's say you're on AWS and you have 100 containers on a host. I just looked this up, but for a long time, you couldn't see traffic between the different containers on a given host because of something about the version of Docker that they were recommending and a couple of other things. So if someone compromised your, call it like a Ruby, because I have written a lot of Ruby and I love Ruby, kind of, in that will I admit to it kind of way. But somebody compromises your Ruby container, then are they also connecting to the Redis instance that lives there that acts as a cache and pulling everything that you need out of the Redis instance? Or are they using the Redis instance as a pivot point to inject some kind of malicious, call it like a delayed job or a sidekick job or something to go then pivot to other machines and other containers, to pivot from your web tier to your worker tier, for example? So dynamism, you used to be able to really pretty well correlate an ENI, which is the network interface that Amazon gives to your EC2 instance, with a certain application. Now, they actually fixed it. So I looked right before this, the way that Amazon, if you're using EKS, the Amazon Kubernetes distribution, then they give each one of those containers a network interface. Now you do have to pay per hour per network interface, but if you're running a lot of containers and you need this level of visibility, then you can get it finally. But having a network interface in a flow log doesn't necessarily give you what container that was. It says, here's your network interface. So there has to be an enrichment step as well. Another issue is TLS everywhere. So these days you can install Istio and you're running in sidecar mode, and all of a sudden all you see out of these network interfaces is encrypted traffic. It's really a blessing and a curse, because the same things that we used to be able to see in security monitoring tools, things like headers and all kinds of stuff like that. Heartbleed might be something that you could write a detection for in some cases, but one of the biggest problems was Heartbleed was all inside the TLS, inside the encryption wrapper. So it was kind of hard to figure out that was happening in some cases. And then we have sort of this DNS accidental fast flux thing where, especially in the case of if you're deploying a lot of internal load balancers, if you're using internal load balancers instead of cluster IPs, all of a sudden you're hitting all of these DNS requests to get to the load balancer. And really, as a security engineer, trying to pick up all of the different pieces to go from container A to load balancer B to container C to load balancer D becomes really complicated. So we can't use all the previous strategies. What can we use? Of course, we've got lots. We can use network security policies. Everybody is using network security policies everywhere, right? 100% of the places? No, nobody does that. So read-only container file systems. Raise your hand if every container has a read-only container file system. Yeah, I'm not running any containers. I can raise my hand. And so there is some flow logging. So if you go to like Calico, for example, you can get flow logs out of Calico. But they don't advertise it because, and of course, we can use eBPF, right, Alex? Is that something we can use? Yeah, okay. So Cilium is a great example. Cilium uses eBPF. It has sophisticated protocol analysis features that is awesome. You can do a lot of things with it. Again, it goes back to the, you're going to have to educate your security organization on how to write network security policies for Kubernetes. I mean, maybe you have that person who's like super into Kubernetes and security and like a lot of other things. And you know what? They're going to get hired away from you in a month or two. It's very hard to retain those folks. So, you have to do a lot of education to sort of get that kind of capability in your organization. Calico, I recently read, is forging into eBPF, so they're going to try to do something that does one of the beautiful parts about eBPF. It's all, and Alex mentioned this, but it all rolls up into LLVM, which is a compiler which takes your code and then makes the executables, but it can also make executables for the processors that live on your networking equipment. That's kind of, a similarly complicated scenario. Cloudflare has a very interesting tool where they wrote a packet capture tool specifically for all of their BPF code, because their BPF code was doing super complicated stuff with the networks, which makes sense. It's fast, but very hard to do diagnostics on. Falco, of course, has been using eBPF since before eBPF. They had their own kernel module, right? Super interesting capabilities, but you have to choose especially as a small security organization. Maybe if you're a large security organization and you have a significant budget, then you can buy into a serious relationship with SysDig or another organization like that, and you can really drink the Kool-Aid and use their fully AI automated stuff to build out your networking policies. I've never been able to afford that. So, let me know if you have, and tell me about your experience with it. So a sophisticated policy framework with broad alerting capabilities, but yet again, it's something that you really have to almost, as much as we spend the time learning about Kubernetes, you have to invest and become a specialist on these technologies. And, there's always the risk from a corporation perspective. They have to do a risk analysis. So if you send somebody to every Falco training and ask them to dig into the code and give them a huge amount of time to really become a specialist on it, that could be a huge benefit for your organization. It could also be a big risk for your organization if that person decides to leave. Kubernetes moves very fast. So we all know this. If you've deployed Kubernetes for long enough for it to get out of date, this. But really, I think the biggest challenge that we have is the combinatorial explosion in Kubernetes configurations. So one of the things for forever, if you wanted network policies in AWS before the security group solution, you had to deploy Calico as a secondary networking CNI inside your AWS cluster, inside your EKS cluster. And that secondary CNI would perform the policy actions while the AWS CNI was doing the routing. So imagine you're doing that. And then on top of that, you have a tool like Istio, which is deploying sidecars to all of these different, to every pod that you want to encrypt traffic to. It can get very complicated very quickly. And so I think, a part of this talk is about talking about strategies for de-risking some of those challenges. And I have a few answers, which are just things that I have sort of experienced on my journey. One is you want to use existing data pipelines. So if you have a kick-ass operations team and they do kick-ass logging, use their and they have kick-ass alerting, use their logging infrastructure, use their alerting infrastructure for your security data. Modern security operations is all about the data you have, and building out alerts for things like that is it's really going to require a data pipeline, which a security organization can't afford to maintain in the absence of the operations folks. So get to know your operations and especially your platform folks very well. A good example here is DNS. So modern DNS, maybe you're running your core DNS instances on every Kubernetes node. You want DNS to be fast. You want to do TCP-based DNS because you're really tired of running out of UDP ports, something like that. So if you're doing something like that, turn on core DNS logging. Get the logs via the normal routes so that you don't have to build out your own infrastructure because it is a big data problem. Communicate. Kubernetes folks, get to know your security operations folks because it's much better to build familiarity there up front. You don't want some security operations guy saying, I need to talk to anybody on this team right now at 3 o'clock in the morning on a Saturday night, right? You want to know them ahead of time. You want to have them familiar with your infrastructure. Ideally, you want them to be understanding your development and staging infrastructures so that when you deploy things to the production infrastructure, they're familiar with that too. And I feel like this is a tricky sell to a Kubernetes audience, but think hard before adopting new technologies. Before you deploy that CNI, before you deploy that additional database, or before you think about using some other networking layer or some sort of cross-plane strategy, think about what the security implications are going to be for your team as a whole. Argo CD, Argo, super powerful tools there, but they're also runtimes, and they're runtimes that now need to be secured. As a security person, it stops being about, oh, what if they commit malicious code? Oh, well, I'm sure we'll catch it before we deploy it. Now the code that gets committed with infrastructure as code is directly the code that gets deployed. So, or the infrastructure that gets deployed. Very interesting time. So I want to talk a little bit about libeBPF flow. I was looking hard. I'm a Unix sort of style kind of guy. And Unix is all about small tools that do one thing well, and then adding the small tools together. So a lot of this slide was about taking the smaller tools. So maybe you have FluentBit for logging. Maybe you have core DNS. Everybody has core DNS, hopefully, for DNS. Turn on your core DNS logging to FluentBit. FluentBit sends those DNS requests, maybe sampled, maybe you want to sample them, send some of those DNS requests to your logging infrastructure. Your logging infrastructure has monitoring in it. Use that monitoring infrastructure, be it Splunk, be it CloudWatch, be it some other tool there, to detect malicious domains from any malicious domain list. So those are kind of the small tools that you can use in a composable way to build out a security monitoring pipeline. You don't have to drink all the Kool-Aid. However, I did want to talk about sort of the Denver Coder 9 moment that I had. So I really wanted something which would generate traditional net flow from eBPF. And I found this super cool project, which I'm gonna show for a second with some caveats. Anytime I go to a GitHub repo, the first thing I look at is when was the last commit? It's over a year since the last commit. So what happened here? Well, this is Intop who built this. They're a well-known name, lots of research in the network monitoring world. And super cool project. You build it. I was able to build it myself, but I had to patch it. It was out of date. And I was able to get these super cool flow logs out of it. It has everything. It has the executable. Can y'all see my screen? It has the UID and the GID of the process. It has the parent PID. So this was Kubelet that was started by systemd. It has the address, the origin address, the final address, the latency. These are super cool statistics, but unfortunately, this tool is kind of dead in the water. It hasn't been updated in a long time. There, if you look, of course, many Kubernetes engines are switching away from Docker. Docker isn't going to be the main container engine anymore, but the primary method to get where is it? In here. The primary method to get the metadata about a given, here it is, about a given container is to query either the Docker socket or this microK8s control path. So this is really a cool project which could fulfill that desire. It could fulfill we have an executable, it's generating network traffic, take this little thing, send out a log, and we can add it to our pipeline. Unfortunately, I think what happened with this is it was turned into a proprietary vendor tool. They thought, this is super powerful. You need a license for this. And I think that's at the end of the day, after an initial kind of whiz bang, sort of PR, blitz. I think that's probably what finally happened to this tool. There's even a Go element that you can use to send out those events. But yeah, like I said, but all that to say, this was my Denver Coder 9, like, this was awesome. What happened to this? It's also very readable. So it's got a make file. You got to read the make file if you want to really figure it out. It has a few little rubs in it, but it also has maybe a couple thousand lines of code. It has everything you need to build out your own BPF-based network pipeline, network monitoring solution, which you can make as a small tool to add to your pipeline. So that's really all I had. Not a whole lot this week, but I did want to sort of talk about some of these things that I've been experiencing.
Hey, Eldon, question for you. So I've been playing around in the eBPF space, especially in the DPDK and XDP realm with that. So this is stuff that's super pertinent to things that I'm looking at these days, which is awesome. But one idea that I just had as you were talking through this is, have you seen any tooling or framework that would allow for kind of integration into these type of flow analyzers into like CI process? Like take my Kubernetes app, it spins it up in CI and then like analyzes the logs for 30 seconds, 60 seconds, 5 minutes, whatever. And like kind of gives a thumbs up, thumbs down or anything like that if it detects like non-baseline, anomalous activity or anything like that.
I have not. And that is something, when 40% of my job was interacting with security vendors, the single most asked question that I had was, I have a pipeline of code. The code starts over here in dev, it gets deployed. It goes to QA, it gets deployed. It goes to staging, it gets deployed. it goes to production, it gets deployed. What I asked for from many vendors, many of whom had this sort of AI-based concept of we'll find anomalies, we'll identify the thing that's broken, you know, we'll look at the behavior, and we have models that will tell us what's good and what's bad. And my most asked for feature was, let me tell you what I saw in dev. Let me tell you what I saw in test. Let me try to make it alert or not alert in staging. And then let me have that confidence to say, this is the rule set that I can deploy in blocking mode to prod. So one of the things, and that was one of the reasons that I actually thought it was worth talking about Audit D, was Audit D is a part of one of the things that it integrates quite tightly with is SE Linux. And SE Linux is a toolkit that you can use to see. It's very similar to some of the seccomp stuff, for example, right? And you can say, block this syscall, block this file access, block these things, and you can run it in a permissive mode. You can say, just log, let me get the logs. And then from those logs, you can build a profile, and then you can run SE Linux in blocking mode to say, I know this is what this is supposed to do, only let it do that. I have not yet, and I've interacted with several, I have not yet run across a vendor that would allow me to really effectively mark a given thing as a mode and then say, this is the mode that I know is effective, deploy it to this future state. And I think, you know, I have great hopes for some of that stuff with like OPA and things like that. As they become more prevalent, I think, you know, my biggest fear with some of those things is they become more, they get pulled back further behind the veil, where it becomes more of a, this is our core IP, you know, which is tricky because they just trained their core IP on your core IP, you know? So how do we liberate some of those policy generation strategies to really make something that's effective? And I've thought about building it several times, you know. It's not something that is impossible to build for sure, but it's not something that I've seen a vendor really readily say, this is what we'll do. And I think there's a significant risk to the vendor in that scenario if they deploy something that breaks you, because almost every system you run in Kubernetes, the business would rather it be up and leaky than it be down and useless.
Yeah, and like in, you know, trying to predict or anticipate or compare against logging, even with like structured logging and whatnot, isn't always easy. But I think these flow logs have the potential to be slightly more consistent in a way. But like as a open source project maintainer and talking with other people, you know, Kubernetes has an interesting thing to where you have this really awesome API that sort of makes this like ubiquitous runtime where I can take it and I can run it on, you know, John Doe's Kubernetes managed service, or, you know, public cloud provider XYZ, you know, managed Kubernetes, or I bootstrap Kubernetes on my Raspberry Pi. And there's a lot of things that, you know, from a project perspective, a lot of times you focus on like unit testing or even functional testing. And you're like, hey, I asked it to do this thing and it did the thing, but you're not looking at like what's the like output and how is that interacting with everything underneath it, you know, based on different Kubernetes versions or kubelet versions or container runtime versions or CNIs or, you know, physical infrastructure and things like that. And I think this brings, like, it gets to a low enough level to where you can really start to have a consistent picture of like, I made a request and I expect to see this request with this PID and this user and this, you know, thing, syscall, at the kernel level. So it's really cool to see that these eBPF tools are sort of opening some of those things up. But if I could take all that and package it up and like run that for 30 seconds or something in a CI flow and just, hey, yes, this follows the baseline, or no, it doesn't, I think that'd be really slick.
I think that would be really slick. And there are even other tools. I mean, we all know anybody who has deployed a Docker image has probably deployed like a gig plus Docker image, right? I'm sure some people have deployed 10 gig plus Docker images, right? And like somebody just tarballed the base file system and stuck it in there, right? And there are in addition to the security benefits, and this is something that I always say when I'm suggesting security is useful, but it's got to go both ways. And one of the core ways that you can provide value as a security practitioner is by telling other folks, I think this would be a way for you to save money, right? So like take that security perspective and then turn it into also a cost savings perspective. So like one of the things that you can do as a security practitioner is you can say, okay, unattached EBS volume, because nobody with Kubernetes has ever lost some EBS volumes because you shut down a cluster and like the control plane died before it deleted the EBS volumes that it provisioned for the persistent volume stuff, right? So as a security practitioner, you can say, okay, part of our controls are no unattached volumes that haven't been attached to something in the last 30 days. And then you can say, hey, by the way, I deleted 10 terabytes worth of EBS volumes that were costing you hundreds or thousands of dollars a day, depending on, the IO config and stuff like that, The other thing that you can say is, let's say you're doing image distribution. I don't know if anybody does cross-region image distribution, right? If you're doing cross-region image distribution, that means you're probably paying for data out from one data center, maybe transit in between, and then you're paying for storage in the other data center. If you can say as a security practitioner, you built this Docker image with curl, but in that profile that you're talking about, Joe, like, we never touched curl. We ran every test under the sun. Curl's still in there. We ran every test under the sun. We never loaded this jar or this other 100 megabyte artifact, this MongoDB. MongoDB got started, and then it created a 100 megabyte whatever those files are that Mongo makes, like the wall log file. We created this wall log file, and now it's in every image, but we've never started Mongo again, right? So I think that there's huge possibilities there as far as, every security issue is also an operational issue, is also a bug waiting to happen. It's something that an attacker can trigger. It's something that a user can unintentionally trigger too.
One more question from me too. So, I work in a large company, and we have very discrete organizations that focus on different areas of the infrastructure. So we have a completely siloed security team, and we have a completely siloed platform team. And I think I've noticed, kind of organically, and not just with Kubernetes, this is anything when you have a very strict siloed organization, but there's obviously large gaps between the amount of security knowledge the platform team has and the amount of platform knowledge that the security team has. Have you seen any major procedural process or cultural things that can help bridge that gap between those two types of organizations? I know there's a lot of tooling out there, say, take any one of the container runtime security, platforms out there. The typical security model of separation of duties of you have the people that define what those policies are, and then the people that kind of have to deal with the fallout of those policies in some way, shape, or form, you know. How to get those people closer together, how to, you know, is it, you know, I've seen some people try to say, all right, you know, it's easier to take some of the security mindset and just sprinkle that into the platform teams versus trying to teach the security folks, you know, all the different platforms and things like that. But just curious if you've seen anything that really seemed to help bridge that gap.
I think you have to have shared spaces, be that like a shared Slack room, be that something, you know, a shared retreat, you know, and sometimes some organizations do those kinds of things. Some organizations don't do those kinds of things. But I think far and away the biggest benefit is to have organizational initiatives have legitimate cross-functional teams associated to them. And really, you know, the hardest part of that is you become a bit of, you know, a servant to employers, right? So you have the employer that is interested in maintaining the integrity of the platform, and the person that is interested in maintaining the integrity of the security infrastructure. And then you have the person that's interested in the success of the initiative, right? And the hardest part as an individual contributor, an implementer, whether it be a security implementer, a platform implementer, or an application implementer, is to really have those business management objectives aligned, right? And, you know, I'm going to be 100% frank with you. I have not seen it occur effectively at an organization that's bigger than about 500 people. So, I mean, it's very tricky. And I think, you know, it's interesting because if you look at some of the organizations that are really top performers, you know, if you look at like a Google or something like that, then you actually see that with some of their, I mean, you know, no organization is perfect because all organizations are just collections of people, but like within some of those organizations, you'll see groups that have sufficient autonomy to consistently be aligned as a sub-organization. And I think the issue that you have is when you have the initiative owner and the platform and the security integrity owners, and those folks can't align on a business objective, then you know, it's going to be very, very hard to be successful. But I think, you know, that's where you look at some of the smaller tools. And I think this goes back to, you know, sort of what I was suggesting there is like, you can't, eBPF is not a zero computation tool, right? Brendan Gregg, working at Netflix, they wrote a meta tool which analyzes the performance of all their other BPF scripts to try to figure out, you know, if they deployed a script, if it would have a negative impact. If you're using a Unix philosophy where you're deploying small tools that are not going to be disruptive on a system-wide level, you can imagine deploying this small tool and just adding a logging stream as being something that's mundane, and then adding value with that, you know, deleting 30-day-old volumes, or, you know, implementing a small policy like that, and then seeing a large gain from it. You can kind of build a bit of an avalanche effect. But I think, you know, I mentioned a couple of times just the change in staffing, you know, the kind of rotation that we're seeing in our industry is makes that even trickier, because you can't take the small gain or the little bet that you did, you know, 6 months ago and say, look, see, this really paid off in spades. Let's make this bigger bet to build something that's, let's send all the security folks to, network policy school for Kubernetes. I do think that in a larger organization, if you have those ISO and those SOC compliance rules, you can say the ISO, and both ISO and SOC, I believe, have some provisions about education, about like continuing education for your employees. So if you can take those things and say, look at this, we need to continue to keep people abreast of the state of the art. And a good CISO and a good CIO will do that. And they will say, we need to reinvest in our people. And that's what keeps people there, in my opinion, investing in them. And then, I have a bunch of good friends who are very smart people. And, one of the refrains is, what happens if I invest in my people and they leave? And it's like, well, what happens if you don't invest in them and they stay? Yeah, so.
Okay. I don't see any additional questions right now in the chat, but if anybody does end up having additional questions for Eldon or for our previous speaker, feel free to send them out through the Meetup in our Slack channel in the Kubernetes Slack org, or the Kubernetes channel in Tech 404 Slack, or open an issue on our GitHub repo, and we'll try to get those questions answered for you. And with that, I'm going to close things out. So thank you, Eldon, and thank you, Adrien, earlier. Both great topics covered today. And as always, we are continually looking for speakers. So if you have a topic that is of interest to you, or if you are have a presentation that you've just been waiting to deliver here to our community, please reach out through those same methods that I just mentioned. We'd love to have you come and present to the group. Thanks again to our sponsor, Sales Law, for providing the Zoom and such. And thanks everybody for coming and sticking with us. We'll catch you next time. Cheers.
Thanks, everybody.